Okay, sir.
Reason. Not at all.
Airtel ఎందుకు రావట్లేదు?
A very, very good morning to all. Welcome all to the episode of the Puttaparthi sponsored, AICTE sponsored short-term training program series 4, which has commenced from 7th December and is going to continue till 12th December. With the theme of role of artificial intelligence in engineering applications. I welcome all participants, the speaker of this session, as well as organizers and the support. Professor in CSC, JNTU Anantapur. Sir is going to speak today on the topic Supervised Learning. Examinations at JNTU. Sir has did his MTech from JNTU Anantapur with distinction. Sir is a PhD holder from JNTU Anantapur, and Sir has got various research projects. Dr. A.P. distinction. Sir is a PhD holder from JNTU Anantapur, and Sir
Good morning, sir. Sorry for the disturbance because we are facing some network issues. Really sorry, sir.
No issues. No issues.
Sir, within 1 minute, ma'am will connect back, sir. Sir, within 1 minute, ma'am will connect back, sir.
Yeah, no problem. Please.
Thank you, sir.
My audible, Prasad Reddy sir, can we start? Prasad Reddy sir, can we start? Please confirm.
Yes, ma'am. You can start, ma'am.
Prasad Reddy sir, please confirm. Can we start?
No. Okay. Hello.
Good morning to all. Very good morning to all. Sanskriti School of Engineering, Puttaparthi welcomes you all to yet another interesting session and day 4. STTP series 4. It has commenced from 7th December and is going to continue till 12th December. It's organized by Department of Computer Sciences Engineering with the title of the speaker for the morning, that is forenoon session, Dr. A.P. Shivakumar, Professor in Computer Science Engineering, JNTU Anantapur. Taking you through the profile of the professor, Sir is presently holding the responsibility of being Professor in Computer Sciences Department. Sir has completed his BTech from Sri Vishwesvaraya Institute of Technology, JNTU, Hyderabad with distinction. Sir did his MTech from JNTU, Anantapur. Sir has got various sponsored research projects. Presently, he is working on the research project, Secured Audio Video File Transmission in DES algorithm. It is sponsored by UGC. Sir has already completed 3 research projects. One on development of innovative software compatible to and he also completed a project on examination management software sponsored by KSRM College of Engineering, Kadapa, which is worth project from Adishankara College of Engineering and Technology, which is worth of 2 lakhs. And Sir has published 15 research papers in various reputed international and national conferences. He also organized and attended various workshops. He also organized FDP and training programs and has been session chair. Sir is guiding PhD students and he is the nodal officer of TEQIP 3. Sir received Outstanding Faculty Achievement Award in the field of cross IF Chennai. Sir, we welcome you to today's session and we request you to deliver your speech, and all our audience are waiting to hear and
Yeah, thank you very much. Thank you for your introduction. It was great. So if you're all ready, then we can start the session. So
Yes, sir, your voice is audible.
okay then. So if everything is okay, then I'll share my screen.
Remote proctored exams, also ask them whether they have selected that or not. Remote proctored exam. No, there's no, you call me.
So is my screen visible to you?
Yes, sir, it is visible for us.
So,
Yes, sir, your screen is visible to us.
Nice, thank you. Okay, so four days you have been listening a lot of sessions. So Prasad Edisa has shared like the lot of topics they've been learning is also one of the interesting things which will be useful for you, part of your research and your career. So as you know that I've been listening a lot of other FDP sessions and other sessions. So what I noticed is that basically we have been listening about what are the different techniques available and all. If exactly how we are going in the deep learning today, and then how the machine learning is happening, the artificial intelligence. the impact of this and how the supervised and so it's during the World War II, the first computer was invented, and they cracked the German code. And this part, the part like the board, I propose to consider the question the commissions can think. To develop this computer, and in his paper in 1950, like in a computing machinery and intelligence, when he has proposed this word, probably people thought it is quite in astonishing what he's saying. But what is the current the computers can think? Now, it is if you see the previous industrial revolutions, okay, your expand is a second mission is where we are going to expand the cognitive skills, the mental power. Computers are not just so the mental labor, that's very important here. So all the industrial revolutions we've been working on how do we replace this manual labor, but is all now probably you may be surprised what I mean to that, because now you have recently heard when a machine learning system called Alphago, you would have heard Alphago. This is a deep learning program which is beat the world champion in the game of Go. Go is a it's a Chinese it's a with a Chinese player, and people thought this in order to master this is very big. So it's an Asian Chinese game which has been much more difficult for the computers to master. Decades of the AI research, we are able to advance and we are able to be the expert in this Go. So now we are very much a revolution in this area. So what exactly happened in the AlphaGo was actually, it was asked to play Go, okay, by watching so whatever the player is doing, what are the different moves made with the player, and they are all captured. And then by playing itself, it started just to learn this, all this we've been learned from taking a lot of examples, whatever is there. The machine started learning either by the playing by itself. To the player, it started learning itself and it started mastering, and find it started beating the human, the best of the person there. And this is very important because that we want to say it is a knowledge which enables the intelligence. We learning is how do we put this knowledge into the computers is the biggest question now we have. So we have the knowledge, and the challenge here is that putting the knowledge to the computers. How do you put this knowledge into the computers? Things which we know intuitively. So we cannot communicate them verbally, isn't it? So we don't have the conscious computers without the knowledge. And what's the solution? The solution is that the machines to learn the knowledge by themselves. So we know a lot of to the computers is about the biggest problem. I know the knowledge. I know each and every, given any particular task, I know what is the solution. But how do we put this to its a knowledge which enables the intelligence? So a lot of research has been done to discover and understand the principles of intelligence through the learning. Researchers believe that there are few key principles that, like the laws of physics. Just like we have a lot of rules in order to understand laws of physics. People believe that in order to gain the knowledge also, there should be some principles, some basic principles. And if we can know that and try understand that and try to make it to the given system. Hello? So if we can give this to the system, okay? Intelligent missions. So if we can understand the principles and give it to the mission, probably we can make a best and best of it in the missions here. So for example, explain the flight of the both birds and the planes. It would be amazing to discover such simple and powerful principles that you will explain in this regard, which contributed in the recent years, the recent revolution of the AI. So with the research on the neural networks and the deep learning, so now exactly the machine learning, has turned out to be two key things which I want to specifically say that, one, use algorithms. Yes. To find a meaningful relation and unordered data. To find the relationship between that knowledge. That learning process. Probably will be so a lot of advancement has been done. So I will be taking some examples to show you. Now it started with speech recognition on your phones with the neural networks. Examples are there in YouTube, which the Google CEO Sundar Pichai videos are there available, where the Google Assistant speech recognition system, which I want to say here. So the first advancement, what I want to discuss is on first is the speech. So first is a speech. So in this speech recognition, I was talking about the example called Google Assistant. So all the smart TVs, they're all providing the Google Assistant. So it's naturally process our language and gives the results whatever is required. It is a very new thing, but people never expected that it will be in every part of the device. Today, Google Assistant is in all the devices, and a lot of other features is happening. But one improved day by day. That's we can say that. So the technology may be the same, but a lot of improvement is done. Find a lot of accuracy has been developed. Language processing. So you can also see that video of that if you want. We'll show that video for you. Detecting the images. So the second advancement is shortly which came is breakthrough the computer vision. So in the computer vision, I mean to say, so we have to understand the most pictures, what we see in the computer screen is meanwhile is all pixels. It's not the image what you're seeing is and computers trying to understand this image. It will first separate them into different features. So now you can see that different features. This is one feature and dividing this is another feature, and they are dividing this is another feature, trying to make this is another feature, and this is another feature. So what objects then it will easily see that still image which has many features. So what I mean to still image, it can be also for the dynamic. Every image is taken as a snap as a static image, and then it starts understanding the objects, and then getting knowledge about the objects of that feature. The computer some information. So now this particular image, once it is detected, this now each and every image will provide some information. One example, so now you can see, now for this particular image I'm trying to find out the area, the parameter, and the skeleton, and so some of the details of these features now, this all will be stored in the memory. When the computer uses, the user gives some to process. Suppose if you're trying to give an image of input something related to this particular object, then it will because already the features is already with the computer. And whatever it is relevant to that. Okay, so it can able to compare what is that is given in the memory and give some output, whether where I need images of the cup, something the details of the cup is already mentioned. So what it exactly says, and just goes to the computer image. You can just in your mobile phone, probably this is also another features available in the Google, just you scan at the mouse, and then it automatically brings the required data for you, images of the mouse or whatever you want to do. Or you can show the bag, it will just scan the bag and says this is bag. It has happened in the computer vision also. Now, so where we can say that the image what we have learned also. So once you scan a particular image, green boxes come into the picture, something like this. It starts blinking that area. It tries to scan the data. This is driverless car trying to assess this, but it tries to scan the data. Some sort of green rectangles and squares appear, and the process computers remember, and it tries to bring the data. So what's happening is that, so even in this model or the model, what I'm trying to do, data. So either we have what you're given in a lot of input data. So I was trying to give a simple input data, and we as algorithm process. So then based on that, we have some algorithm, a learning algorithm, and that exactly gives the model for us. So parameter and skeleton. So these are the data what we have gathered, and computer knows these details. And when the user gives the input is given, the model recognizes, because the model, I learned the features, what are the features I have said, area, skeleton, and parameter. So it matches with the what exactly I have shown is the area, parameter, and a skeleton. The computer focused in future, you can classify more, you can take more features of the image, or you can just study that image into more and more details. So this is something. So another is another is a computer vision, one of the beautiful two areas where a lot of advancement is happening. Here, are you all with me? How about the speed of mind, and then if you're just speed, and if you are not understood anything, we'll go back. So in between, I'll try to break and then ask you if something is there. So now,
Yes, sir. Yes, sir. We are clear, sir.
so okay, then it's good. So we'll go further into this, the same thing which I depicted here. So yes, the same thing I have depicted here. Now this is an this is a training data here, and that's what I was talking about. Now once we have an historical data or the previous data, the random sampling, we have a statistical model. This is a model. And this is a model, what I mean is something, you've taken a previous example, area, skeleton, parameter. So we have stored here. And once you test, give a particular data set, and then this model is used for the prediction and validation, and whatever the output is come. Something like this, machine learning model we are training with, and you use some machine learning, and then we build a model, and then based on the, and then it processes and gives a particular output of the model. Okay, and same thing happening, even for the Google translation. In the translation, exactly, if you see the Google translation, area which I want to discuss, probably we say a lot of advancements which have been used, and then we have been a lot of happened on this translation also, where the machine learning and the deep learning is used. So there are signboards of the different languages, and you don't know what, and if you are looking at an hotel, you know, so probably it was not easy. Remove that all the difficulties. Now just you can scan into the mobile particular board and it says what it is inside that, isn't it? Yes. Any issues? So what is an again artificial intelligence, we can actually gain a greater understanding how most of the AI is works. Okay. Now it's been almost 20 years plus, 10 years plus. Now, when it's first launched, you may notice that the translate is getting is more faster and more accurate. And you know, a lot of stuff. It probably you can. I was looking for my difficult for me, so I try to translate that into. So what I seen is a lot of accuracy has been improved. A lot of accuracy. No, it is basically, if you can remember, it's like a training, just like in your school, like where the maths teacher was saying, um, then you will be more better. And the same with music or any other teacher, where when you're practicing learning and learning, because it's learning. This is expanding the computer's ability. So either it is a speech recognition, which I was talking about. Another is the or the latest one which I spoke now, the Google Translate. Is that the computer expanding the computer's ability to understand the general natural language, or it's being improved 10 years back, and the way it has been improved, a lot of advanced, and definitely there is a lot of, definitely there is a concepts of deep learning, the artificial intelligence. In a lot of roads to us, and where a lot of applications being used, isn't it? Now, having said that, yeah. So having said that, but what we have to understand is that very far from the machine that would be able to, like humans, and to learn and master many aspects. But I still, can it match human is one of the biggest challenge we have. So yes, definitely it's a big challenge, and a lot of, yes, but potentially the areas where we feel like a lot of advancements has been done, and in order to get a human perfection, definitely takes a lot of time and the research. That's the reason people are saying there's a lot of scope for us here in this area. Even if you take a simple example, let's take a 2-year-old child is able to learn things that the way computer not actually master the intuitive physics. She knows when she drops a ball, it is going to fall down. When she spills a liquid, she expects that actually teach her exactly, like, if you throw the ink bottle, all the mess up will happen, or if you just drop the ball, this will fall down. This is the Newton's law 1, and then this is Newton's law 2. But basically the kids have learned in a beautiful yeah. So here I want to drive that in basically a lot of unsupervised way. The same thing basically, it's actually remains as a challenge. Key challenges for the AI. So humans, we are very much strong in this unsupervised way because it can learn the things in unsupervised manner. Yeah, yes, it's a big challenge for us in order is required in order to discover these particular patterns. So for that, let us, if you can take a simple okay, now come to this page. Okay. So what you are seeing to what you are trying to assess, can anybody say what I was trying to present? This computer will see from this. What is the first impression for the computer? Can anybody say this? What is trying to see that? What is that? Now I see in a page here. I say this is a page. Now you are seeing with your eyes, and there is some content, but yes, for a computer, what is the space? So in any small encouragement that you're all listening to the class. Yeah. Yes. Anybody is there? Trying to. What is the first impression for that? Anybody from college said you're there, no problem. You can also say. Probably I had to proceed now. So now, see, the moment it is seen as a page, but for the computer, it is all pixels. This one isn't, but for the computer, it is all the pixels. So in order to answer this question, the image, probably you need to understand the high level meaning of this. Now, the high level meaning is something which happens at this end. Now, if you can observe here, so the high level meaning correspond to the high level representation. So we are trying to, as I told, the simple basic rules we have for the physics. In the same way, there should be some basic principles in trying to sort of simulate that, trying to understand in that manner. So the high level meaning is the one exactly goes in the different understands what exactly what is there in this particular letter and all. Okay. So low down have the individual meaning of the words. So here we have a, now we can just go back to the screen here. So this is a the letter is all about that. And in the lower level, it is on all asking, trying to find out what is the meaning for something like that. Okay. And then it tries to understand what exactly, what are the characteristics available. Okay. Lower down, we have those characters which can be rendered in different strokes. Like this and this and this like this. We have a different strokes and it make up those characteristics. And those edges are made up of pixels. So these are the different levels of representation to make the sense of the image, to answer the high level question about the content of the page. So your brain so in the same way, probably trying to understand this is a high level meaning. Then in the lower level, we have a next level, we have the stroke, and the strokes are made of the edges. And down the line, this is all made with the pixels. Okay, now the input goes to the second stage, and this input goes to third stage, and third stage, finally, we get the high level meaning of that. What do you mean by V1 and V2 area in the brain? Try to understand this. Now, if you can understand this, here we have the edges here in this V1 and V2 and V2 has these different levels of representation, starting with the neurons in the first visual area of the cortex V1. So this is a V1 and V2, and this is a neuron. This particular neuron in the brain, maybe you can just imagine something like this, your neurons, which is connected. So this is a V1 and a V2, and this is a V1 and a V2, and yeah, this is the level of the V2 here, V2, V2, V2. First, it try to recognize the edges in this area, and then neurons in the second visual area is a V2, isn't it? Which recognizes tries to understand strokes and the small space shapes here. So the same thing what I represented here in the top is the same level. Here we have the vertex 3. So higher up we have neurons which detect the parts of the objects. So neural networks, when they're trained with the images, can actually discover this type of level that match pretty well that we observe in the brain. So it's something like this which happens probably brain takes data from one neuron to another neuron, neuron to neuron, and another neuron, and ultimately, and then we'll try to revert back the reply based on what we understood, isn't it? So the high-level areas of visual. In the both neural networks, biological neural networks, which what you have in your brain or in our machines can learn to transform one level of representation to next with a so what we're trying to probably understand is that we are trying to make even the levels of understanding, levels of hierarchy of understanding, just like the biological brain, and we are trying to get the data from one of a character A. Character A can be rendered in many different ways at a lowest level. So even if you understand, trying to understand A, character A, okay, something like this. So many and so on. You can just see, something this probably it is something like this. We can say it's a C, and then this is the E. We have forms different letter. So we have the configuration pixels depending upon the position, the rotation, and the font, and so on. Sort of rotation, and we're trying to get more and more data, isn't it? More and more features, and so on. We learn this from edges to the strokes, strokes to characters, characters to the meaning, meaning to the high-level meaning. In this way, so what is one of the beautiful thing. The one thing that has been very successful up to now, application of the deep learning. Currently, there is a lot of advancement that's been happened, and a lot of improvement has happened in the supervised learning. So, in the is to be taken by hand and humans to tell the computer the answers to many questions. What is so you're all with me?
Yes, sir. We are with you, sir.
Okay.
Yes, sir.
Okay, good.
It's clear, sir.
Okay, that's good. That's good. Okay, now. I just given a brief what do you mean by unsupervised? I know by the terminology what do you mean by different methods, linear regression and all. Before I want to present what exactly mean unsupervised. People think, we are in day in and day out, we have learning a lot of things with the unsupervised way. I just want to, as I told that, we have done a lot of advancement in the supervised learning. What do you mean? Actually, we actually train basically that, we feed. For example, in the millions and millions, so we have some millions and millions of images. Just you see here, a lot of images. Oh, what is this image, and what is this image, and what is this image, and all these things. Now, in this, if you say, now you give the image, and this is a laptop, and this is a keyboard, isn't it? So, and so on, and all the millions of, and probably you have to go and say, and what is this image is about, and what is this image about, and what is this image about, and all. Yeah, it needs a lot of management. All the very powerful, but and they, but what's happening as the TDS I is told. So they, so but what we already thought is that can it happen in a more autonomous way? Just I do then you will understand it. It throws the ball, it drops down. It's more in autonomous way. But what we are trying to learn is this data and all of that. So unsupervised learning basically could do help us do with the self-driving. The unsupervised learning allows the computers to present themselves in the future, where it generates on the current situation and allows the computers to reason and plan ahead. Even the circumstances of the supervised learning, we could have to tell the computers about all the circumstances where the car could be and how the movements react. In a real-time world, it is not possible for the supervised learning to do miracles to us because just I was not understand the behavior of the machine, or when it is goes to the live, we cannot expect the dangerous behavior. We cannot train also. Now imagine, like if you just imagine that the Google driverless car comes to in our area, especially in Anantapur, if you, we don't know whether the police is saying to go or to stop. He gives a signal in between. I don't know how the machine will react, and all of a sudden, driverless car is coming with a set of rules. You have been trained your machine in the supervised way, and you're not expected the dog comes in between. So now what the machine. So definitely this won't work. And definitely the supervised, even though it is a wonderful one, a wonderful learning technique, but it's not possible for the supervised learning to do wonders. So it is not possible for us, where Google driverless car. Suppose if I go and hit it 100 kilometers, what will be the damage? Or if I go and if I take drive, what degrees I'll fell down. So I cannot do experiment of that. I cannot fell down myself and say, boss, this is where I can. So if I fell down, I'm not there. For us to do a lot of things in a supervised way, isn't it? So probably something what missions way. So yeah, we are trying to know the importance of the supervised. So we are trying to make progress in that. Definitely, what we are trying to say, we are doing a lot of progress is there. Where we go to the high level meaning of the pixels rather than the pixel to the high level meaning. We are going that are new images different from that the computer has seen while it is trained. So basically, we are trying to get into directly the high-level content. Create an image of high-level image. The brown house, a green field of the grass in front of the dogwood. So probably trying to directly target the try to directly attack on the high level meaning instead of starting from this level also. In case if you are but we're trying to feed the high level meaning to the system. So that's what one of the advancements. So maybe see about maybe another 15 years back. So unsupervised discovered something in the deep loop before this deep neural networks has come. So the unsupervised was definitely a breakthrough for this in this direction. So as many of us know, happening is the importance of towards the social value, a lot of applications in the health and all these things. The treatment, personalized medicines. Yeah, definitely we have a lot of advancements which has happened in this area. Even the data science also comes into the picture, because when I say that we are trying with the more data science has a big role to play. And yes, so a lot of it's not deep. And then we have the data science, we have the machine learning. So sometimes this all and in order to train the machine we need to have a good data. For that a lot of other data science principles. So all yes, so we collect data from millions and millions of people around the earth, and we'll be able to provide medical advice. It was surprising when one of the article people were saying that the cancers, the different cancers, probably once it was given to the data science and trying to get the data of all the cancer patients. In addition, it has identified. So yes, and suppose if the beauty of that, another thing is that we need not do the things from the scratch. Have used or people have predicted some of one treatment so and so it is a high success rate. They need not do from the scratch. So a lot of it helps in a lot of medical advice also, and we can imagine AI, artificial intelligence. Something that will come out, the research is definitely the natural language, understanding the kinds of review here is that what's happening if I'm seen in this examples way, and how the different advancements is happened in the areas of translate. Okay, so this is a different the topic of our different tactics of supervised and unsupervised. So we have maybe another. We'll just quickly revise basically the concepts of that, and one or two examples I'll try to focus. Okay. For you, where okay. Now, so yeah, you're all okay till now. You got basically with the basic real-time examples.
Yes, sir.
My concept was before I thought of starting this, I just want to give exactly that idea of what I was trying. Okay. So there are basically three types of learning. People are always saying that now what I. So this is one is a supervised learning, another unsupervised learning, and then the reinforcement learning. Fraud detection, email, spam, and the diagnostic and image classification. We have risk management and the score prediction. The big data visualization, and we have imaging. Then we have the clustering. We have the biology. We have the enforcement, the gaming, the finance sector, the manufacturing, inventory management, and the robot navigation. So if you classification, we have told about like we can use set of images to the machine with all the features, feed it to it, and new was about. So in the same way, when we are talking about the clustering, is all especially in the biology, like where cells with another features, we want to make a different clusters, and of course, the cluster each cluster has own set of properties. Yes, definitely. We'll just so we what exactly we have. One of the most popular technique which we have been said, and it's used precise mapping between the is talk about that a supervised learning is a labeled data, meaning that the algorithm identifies the features explicitly and carries trained as a training period progress. So the algorithm is able to identify the relationship between the two variables. There is an input data which I was talking about, and then this is, and based on this input data, we are trying to build a model based on this, and this model is basically once you give input for that, then it is going to prediction. Now, hope you're clear with this particular thing. So we'll take one example. Take very easy understanding. So let me share the screen where yes. Yes, I'm sharing your share. Yes. Now, if you can see in this, we say it's a classification example of supervised algorithm, the decision tree. A particular example. Okay, so now if you can see this particular image here, this is a decision tree. So here now this it whether for the given condition, particular whether for this condition can be placed. Particular screen. 1 second. We'll try to open this PDF file of this. Presentation. Okay. We don't. So now we have the famous Hunt's algorithm identification. Now, if we can try to see this algorithm. So given an element n and the m decision sets from the previous iteration, identify sets of the decision classes for each of the item set. If an item set has only one decision class, identify the set of decision classes for each of item set. If the item set has only one decision class, what I mean to say is that here, and if you can see, this is a famous decision tree example. Temperatures are mentioned here. So we were not that much interested on the temperature in the numerical values. What we're trying to do, we're trying to put with the and the pleasant and chilly and warm and then this. So if we can observe this on a sunny day, and another sunny day is yes. So with the input variable, if with one parameter of outlook, what we are trying to see in the what happens when the outlook is a cloudy. So the outlook is a cloudy, sometimes it is yes, and some able to when we are unable to predict whether the match is going to play or not going to play when the outlook is something like something like overcast, or sometimes we can say yes and we cannot say yes. So this is one probably what. So if But if the outlook is cloudy and overcast, we are unable to predict what is going to happen. So because this is clear, we will remove this particular part and we'll try to consider another parameter into the picture. Now, what we're trying to do for the same cloudy and there is a warm here, okay? If it is a cloudy and warm, we and chilly, it is no. And if a cloudy and pleasant, yes, it is yes. So what we're trying to do, this having is going to happen. And if you take another example for this, yeah. So if you can do that, oh, yes, yeah. In the same, we will try to do for the overcast. Try to treat the addition to induction. So what we are saying that it's a bivalent. So basically, it is a single state. Bivalent state yes or no, and what the given input is a sunny, then match is yes. Yeah. Then if it is a cloudy. So that's the reason we'll take another parameter in the picture, then we say yes. And if it is chilly, it is no. And if it is the match, if it is chilly, yes. Yeah, if it is chilly, it is no. And if it is pleasant, yes. So, and that's the reason we are removed from this one. Now, given an input that it says, okay, whether the match is going to. If you ask a question, given it is a cloudy day, then we will ask definitely the another parameter like, okay, whether it is warm. So this is a classic example of, where we are just yeah. In a supervised learning where you have a label data here, and that label data now you can imagine that model is something like a decision tree here, what I was talking about. So I have drawn one decision tree. So I have one decision tree for that example, and then I just give the input. So within this is a sunny day. Now whether the match is played, yes, it is played. Something like this. Now, yeah. So the resulting supervised algorithm is basically task-oriented as we provide with more and more examples. Undertaken task yield as an output more accurately. And some of the algorithms that come under the supervised learning is all follows here. Random forest, and we do have the gradient boosting. We have the subtour vector mission, and the logistic. We cannot go to that depth, but probably we're just given the concept about. Okay, so there is another learning case for this supervised algorithm. Okay, then next we will go to the unsupervised. In the case of unsupervised learning algorithm, the data is not explicitly labeled into different classes. That is, there are no labels at all. patterns. So unsupervised learning algorithms identify the data based on the densities, the structures. So basically, if you can see the major difference is that it is a similarity which makes the unsupervised one, where based on similarity we group the things here, but in basically on the similarity, and in supervised basically basically it's on the dissimilarity. We'll try to divide the objects. Is based on, so Hebbian learning cluster analysis is one of the mostly used techniques in supervised learning. Now let us look. Okay, so you're all able to follow?
Yes, sir.
Yes. So we have the fruits we're trying to group into based on either it may be the color or the shape or the different other features we are trying to build. Where we have two algorithms basically, which the k-means and the db scan and the hierarchy. So, yeah, one unsupervised clustering analysis, you can just see one learning case here. So another which we have. Yes. So one is we have been you have this particular algorithm. In this, if you can see, control tree and j is equals to 1 and k1 and the clusters. So here the clusters, number of clusters are not defined. And the number of clusters it is going to bring is, we don't know exactly. Find the k nearest with the xi, find the nearest then create a new cluster and k is to k s1 and assign xi to the game until j is greater than 1. So go back to the presentation. So yeah, so yeah, what we are trying to yes, so what we are trying to, the k nearest is something. So yeah, we try to of this, and we every time we take the distance. Yes. So now find the nearest neighbor of the xi and let the nearest neighbor to be in the cluster M. To say is that initially it will be in some cluster. Okay. Yeah. Do have something like we k nearest neighbor, probably we take except xj and we name this as a cluster M. All we make this as another cluster one, and there is a point here. And if we having made this two as a clusters, we take the is this one, then probably we move this particular object to this particular centroid. This is the clusters goes on evolving, and a point will come where applies, and then it holds good for all the values, and we close the algorithm and we say this is a number clusters. We are not sure how many clusters will come. So this is one type of algorithm we have. Another clustering is iterative clustering. Iterative here basically given n elements and then k clusters. Here we define because the number of clusters is known, so we try to restrict the output of the clusters to whatever the clustering we have. So these are the two clustering examples which you are familiar and which are being used. So let's go back to yes. This is which we are discussing here. Okay. So here is one of the most popular unsupervised learning techniques. That's the potential customer base. Yeah, segments for selling their products. Say how the clustering business we're able to capture the potential customer segments by selling their products. Can anybody talk about that statement here? Yes. So can anybody just say about that? We are able to capture the potential customer segments for selling these products. So basically, and there is a very interesting thing do happens. Even if you are trying to find, the famous, if you can see, there is some trend which happens either in the selling or the way the customers are there. Thing happens. Probably if you can take one of the supermarket, which is very near to the, very near to where a lot of housewives are there and something like that, where the patterns of their shopping is something different. But if you are their shopping is something different, so it all depends upon the customer behavior is different, the way they purchase, the way the behavior, their purchase behavior. So this has a lot of impact. Probably that initially that how they are going to what exactly inside this one. So the machine is trying to learn itself in an unsupervised way. The sales the companies can evaluate the customer segments and then decide to sell their product to the maximum of their products. Ways for they're more focused for this particular products in that area, and they're not that much particular of the money aspect also. Okay, so one such company is performing a brand marketing analysis using machine learning is an Israeli is to ingest and process the customer data in order to make it accessible to the marketers. So they take one step maximum profit out of the product marketing. isn't it? So identify the potential customer base for selling the product. And selling the product to identify the customer group. Now you can just, of course, yeah, this evident clusters or the customers with the same set of common features or similar features, probably. So provide some offer to this particular group. So if you see that one of the market has a lot of customers related to this, probably they can explore. So the last thing is reinforcement learning. This basically, allows the machines to interact with their dynamic environment in order to reach their goals. With these machines and the help of this reward feedback, agents are able to learn the behavior and improve it in the long run. Reinforcement signal. So probably you know that what I told initially in the Alphago is a game which was it's basically the machine is not at all aware of what exactly it has to do. Then it it so the agent in the environment is required to take actions that are based on the current state, and this type of learning is different from the supervised and in the former has an output mapping provided such that the model is capable of learning the correct answer. Whereas in the case of reinforcement, you have to perform a particular task. So when there is no training data set, it learns its own experience. So Google's active query answering that makes use of the reinforcement learning. So it's question answer, active questioning answer. What is the birth of Nikola Tesla? What is the birth year of Nikola Tesla? Then when was Nikola Tesla born? What is Nikola Tesla body? And this Google has integrated the reinforcement learning into its system to better interact with the query based on environment. We have the user here. So now this is an environment of the questioning. So it reformulates deviation from the traditional sequence to sequence model, says that all the tasks are carried out using reinforcement learning. For a question QO, we want to obtain the best possible answer A star. The goal is to maximize the so now we different types of machine learning paradigms which we have seen here. Supervised these three categories. So real-time applications and all. So is that okay for you? Yes. Hello.
Sir?
If you have the audience has a questions, then we'll be better discussing on the questions. 40 slides, but this is more into the learning more into depth of analysis. So how examples, or So I just want to try to get exactly the what is their level, and then
Sir, like we have 20 minutes more, sir.
yeah, okay, no problem. So anyway, we have I just given just just take 1 or 2 questions, then that should be fine instead of discussing all these things. So because intuition, like what is some inputs on supervised, unsupervised. So what some yes. Is it loaded, the session?
Sir, we have some doubts from the participants, sir. Sir, like speech recognitions and computer vision, we have talked about it now, sir.
Yeah.
What are the advanced ways, sir, from then and now?
Question, like if you can see the advanced way, you can see. So as I told you, the way back in 15 years back, this speech recognition system has come. I remember when I was doing my UZ, we happen in terms of accuracy and the fastness. That's two areas which people have done a lot of improvement in terms. I was just looking at some of the videos of Sundar Pichai, like what he was trying to see. If there is what it will understand is that earlier it was to understand that it is in the particular bird is in swimming. Now, if you can, the same input image which you are given way, some years back, and if you give the same input image to the, it says a bird is in a swimming position, sitting on a rock. Yeah, so like this, definitely there is a lot of when you're looking at speech recognition in terms of the especially the reason why regional content, the people, how the people in Tamil, they speak English in a different way, and then people in Andhra, they in different way. So now the speech recognition is trying to normalize that part of that regional effect. What we say, we try to pull the particular words which is not exactly the pronunciation of the words, but basically we speak to the Google Assistant in the same way the way you speak now. It's more clearer. Try to understand the different pronunciations also. Something like this. See what is trying to one thing we should understand. The same thing I told with the Google Translate also. It's being improving. That's it. It's we cannot replace human definitely, but it is learning and then improving, learning and improving.
Sir, and we have one more doubt.
Yeah.
In the three ways of learning, which would you say the best one?
Yes.
Sir, am I audible?
Now it is audible.
In the 3 ways of learning, which would be the best way?
Yes.
Sir?
Yeah, please proceed.
In the 3 ways of learning, which would be the best way?
Hello?
In the 3 ways of learning, which would be the best way?
because you're definitely sure that the results will come to you, but it is not possible as a humans to imagine all the conditions, all the real-time conditions which can happen, and definitely we have to depend on unsupervised. So they each has each has its own limitations. Okay, so we cannot say something best. So what we are trying to do, see, I was talking about an example of a cat. Now we say this is a cat. And then this is a cat. But but there are some millions of images there. So instead, what I was trying to do, so then it will try to understand from this one. So yeah, supervised way is definite. It has got a lot of the machine is given the freedom to learn, and where the humans effort is not required, the machine will learn, put effort, and then try to learn the things. Where the Alphago was designed based on the new environments, it tried to. So there is nothing like basically based on the uses, based on the work, probably which learning to be taken. It all depends upon that. Suppose you have a system is something like this, where you have the entire data, whatever you want to, whatever the results you get, whatever the data for it, and then it gives output for you. But it's not happens in a real time. So it depends on the situation.
Thank you, sir.
Yeah.
Like we have completed all the questions.
Part which this is basically, I'm sure that all of you would have gone test topics. An example. So now the algorithm goes here. We don't have that much time to discuss, but definitely it formulates a model of a decision tree, and then so based on that, next time it is going to decide whether it's going. We have different algorithms here. So anomaly detection, we have the Gaussian mixture model, we have, yeah. So there's a lot of scope for us, those who are really working, especially those who are doing research. Very surprising. I was reading one of the talk where people say the entire deep learning, and he says if somebody can do it better also, then it's very great, and an extraordinary business researcher in AI. So yes, because you want to do research in this area, a lot of problem areas are there, and then so you can given set of data, can we do something more into for which type of data, which learning model is best suits. To point, so different aspects. There's a lot of scope is there, and into the layers, into the performance of the layer. Topic which you can explore because a lot of social value is added to this and definitely it has a much impact in terms of advance, in terms of the research, the opportunity is also very high. So I feel like this is a good opportunity, and okay, maybe like if you have some more questions, we'll take up, or then.
So we are done with the questions.
Okay then. Okay, so if something. So if not.
Yeah, sir, thank you so much, Shivakumar sir, for a
Yeah.
wonderful explanation. For the participants also. A lot of interaction happened with can machines think. Participants will start getting involved and start participating. So
Yeah.
and the way it started off and ensure which we can relate more, Google Translator, which we often use.
Yeah.
So unsupervised way of learning, you have explained beautifully. Learning and the classification techniques and decision tree also were explained very nicely, sir. Shared the research thoughts, I think, which you have published, so that that participants can relate easily how they can present. Thank you very much for being with us and sharing your knowledge and insights into the topic. On behalf of Sanskriti and paying attention to the session. And now we are concluding the day for forenoon session. 2 o'clock, and kindly be present 5 minutes prior to the session. Thank you so much, sir. Shivakumar sir, once again, thank you.
And your management, sir. Thank you all. Yes, sir. Yeah. Thank you all.